Hi friends. This CPU can require as long as 26 weeks to make, in its upwards of 100 layers. Billions of semiconductors are pressed into a region about the size of a fingernail. They're the cerebrums behind nearly all that we use in our undeniably electronic world. This is the way these complex minuscule gadgets are made. The cycle starts with silicon-rich sand. Why silicon? Silicon is a semiconductor. It's the perfect balance between a cover and an unadulterated guide that implies its properties. For example, its conductivity can be modified by adding debasements or doping to meet the necessities of various electronic gadgets. This additionally permits us to control the electrical signs that pass through. Silicon is additionally plentiful. It's one of the 10 most normal components tracked down on the planet. However, a significant part of the silicon, saw as in the wild, is synthetically bound to oxygen, so the two components should be isolated. The sand is joined with carbon and softened in cauldrons to deliver carbon monoxide. What's more, 99 unadulterated silicon after additional handling. Ultra-pure silicon is delivered next. A seed precious stone is set in touch with liquid silicon. As the seed precious stone is gradually pulled away, silicon particles are kept on the base surface. The result is an enormous barrel-shaped bowl or a single gem ingot of unadulterated silicon. The bowl is then meagerly cut into wafers. Silicon wafers ordinarily have breadth of 1 to 12 crawls, with the most cutting-edge offices being capable to deliver wafers up to 18 crawls in measurement. Greater wafers are obviously ready to yield more computer chips. When the silicon wafers are cut, the creation process starts in full. Computer chips are made in very sterile conditions, liberated from foreign substances such as residue. On the off chance that even only one molecule of dust advances onto a silicon wafer, the whole bunch is in danger of being destroyed. This would wreck an interaction that can take a normal of 12 weeks. The initial step of the creation interaction is statement. A meager non-leading layer of silicon dioxide is developed or saved on the outer layer of the wafer. Then the silicon wafer is ready for lithography by covering it with photosensitive and light-safe materials. The subsequent stage is extremely basic. Openness. The prearranged silicon wafers enter a lithography machine and are presented to UV light. Went through a reticle containing the chip's diagram. The regions presented to light are solidified, while unexposed regions are then scratched away by hot gases to leave a 3-layered microprocessor. The electrical conductivity of various portions of the chip can likewise be changed by doping them with synthetic substances under heat. What's more, pressure. This cycle can be rehashed many times for something very similar. Chip delivering a more intricate coordinated circuit at each move toward make leading ways between the parts. A slender layer of metal like aluminum is overlaid onto the chip, and the carving process is utilized to eliminate everything with the exception of the meager leading pathways. A few layers of guides isolated by glass protectors can be set out. Each chip on the wafer is then tried for execution before it's isolated from different chips on the wafer by a saw. Since computer chips are basically circuits based on an inconceivably limited scale, they have a fundamental set of parts. Capacitors can briefly store an electrical charge. Resistors help control the electrical current. Semiconductors can either enhance or, on the other hand, switch the electrical signals passing through for further developed chips like those found on very good quality designs cards. There can be as much as 28 billion semiconductors on board. More semiconductors on microprocessors permit them to convey more directions, expanding the computational power. Moore's regulation predicts that central processor assembling would progress at a consistent rate, permitting semiconductor builds up to twofold at regular intervals. In light of the sheer force of the innovation we use on an everyday premise, this decades-old expectation appears to still be generally obvious. Makers have been contracting down their semiconductor sizes to fit more onto chips. Each leap forward in semiconductor size has permitted the development of all the more remarkable chips for our telephones, PCs, and gaming consoles. As of late, they've gotten every semiconductor down to as little as 8x10 to the force of negative 8 crawls in distance across, permitting an astounding 50 billion semiconductors to be packed onto a solitary chip. Fabricating a central processor is really one of our most intricate accomplishments, but then Developments are occurring consistently. Thanks.